Hello, so in this video we'll look at integrating fractions, okay? And we'll particularly look at integrating fractions of a particular type. So we've looked when we're dealing with integrating fractions using integrations by substitution, but sometimes you can use this idea of an antiderivative, which is what we're talking about in the last video. So remember, an antiderivative says, well look, I know when I differentiate a function I get this, which means that integration should just be the reverse process, which means that the answer, if I'm integrating this function, should just be the original function that I was thinking of. So just remember that if I want to differentiate a natural log function, so something like the natural log of a function of x, okay, so that could be like the natural log of 3x plus 4, okay, well that should just be equal to, by the chain rule, the function on the denominator, so the f of x on the denominator, but the derivative of the function on the numerator. That's just simply the chain rule. So what that means then, is that if I'm trying to integrate a function of this type, so where I've got the derivative of the function on the numerator and a function on the denominator with respect to x, that should just be equal to the natural log of the original function, or in other words the function on the denominator, plus c. Okay, so I think we can use that with these next examples. So let's have a look at this. So I have the integral of 5 over 3x plus 5. Well, okay, if I want to use this fact in red, then I basically need the derivative of my denominator function. So my denominator function is 3x plus 4, but derivative of my denominator function is 3. I need that on the numerator. Well, I haven't got 3, but I've got 5. That's okay, because what I'm going to do is I'm going to pull that 5 out, and I'm going to write my integral. I'm going to write my denominator function in, so my 3x plus 4, with respect to x. But I'm basically saying, well, what would be really nice here is if I had 3, because then that would be the derivative of my denominator function. Well, obviously I can't just put a 3 in there and change in the question. But I can, as long as I divide by 3 out the front. Okay, so it's almost like a fudge factor. That timesing by 3 and that dividing by 3, they cancel each other out. So I've still got the original thing that I started with, okay? It's just I would put a little fudge factor in there for me. So now actually, it's a relatively straightforward thing. I'll just end up with 5/3. And then I realise that this situation is exactly the same as the situation I've got over here in red. So this should just be equal to the natural log of the denominator function, which is 3x plus 4. And don't forget 2 plus c. Okay? So it's as simple as that. Now, just a word of warning. This really only works if you're off by a factor. So in this case, I had the 5 on the numerator, which is a number, okay? So I wanted 3 on the numerator, which means that I could divide by 3 here, okay? Now clearly, if I had something like x squared that I was missing, so for example, if this was x squared, then I couldn't put, for example, 6x here and divide by 6x out the front. That's not allowed because I'm dividing out the front by something that I want to integrate. I've got a variable in there, okay? So this really only works if there is a number there, okay? So it only works if there's a number, not if there's an x missing or something like that. Okay, cool. So let's have a look at the next one. So with this one, we got the integral of tan of x with respect to x. Now you're probably sitting there and thinking, how on earth can I use this fact in red, this little formula, this little idea that we've sort of thought about, because I've not even got a fraction going on. Except we have, because if you remember the identity that tan of x, so tan of x, is just equal to sine of x divided by the cosine of x, okay? You remember, just think about your right angle triangle and you can derive that relatively easily. So in other words, I should be able to write this as the integral of sine of x over cosine of x with respect to x. Now, in order for that idea in red, this idea here, to work, I basically need the derivative of my denominator function on the numerator. In other words, the denominator function is cosine of x. The derivative of that, I need that on the numerator. Now just remember, the derivative of cosine of x is negative sine of x, not just sine of x, which is what I've got on the numerator. But that's okay, because if I put a negative on the numerator, then I should be able to divide by the negative out the front. So I'm just going to put a negative there, because the negative and the negative cancel to make the positive anyway. So it's again just a bit of a fudge factor. I'm just basically putting -1 in there. I want -1 sine of x, so I'll divide by -1 out the front. Okay? So now I'm in a position to say, well, okay, I've got negative. This is now the situation that I was looking at before. So it should just be the natural log of the denominator function. So the natural log of cosine of x with respect to x. So that's the integral of tan of x.